Friends, hydrocarbons talk about faults. Carbon gases talk about insulation life. But oxygen and nitrogen talk about breathing. Every transformer breathes. But not every transformer breathes correctly. When oxygen increases in DGA, it does not mean overheating. It does not mean arcing. It means something far more silent. Air is entering the transformer. And when oxygen enters, paper insulation ages faster, oil oxidizes quicker, and transformer life shortens quietly. In today's Electroverse episode, we decode oxygen, O2, nitrogen, N2, and the O2-N2 ratio, why O2 and N2 are always present in oil, difference between normal breathing and air ingress, how O2 accelerates paper aging, why absolute values are misleading, how the O2-N2 ratio reveals leaks and sealing problems, and how senior engineers detect breathing failures early. Stay till the end, because O2 and N2 do not announce failure, they silently prepare it.
Now we address something silent, slow, and extremely dangerous if ignored. Air ingress. This episode tells you whether your transformer is truly sealed and protected. We're diving deep into the technical aspects of dissolved gas analysis, specifically focusing on oxygen, nitrogen, and their critical ratio. As an experienced engineer, I'll walk you through why these gases matter more than you think they do. Let me start with a fundamental clarification. Oxygen, O2, and nitrogen, N2, are not fault gases. They are environmental gases. They tell us about system tightness, not internal faults. Think of them as your transformer's breathing pattern. When this pattern changes, it reveals whether your equipment is properly sealed or slowly suffocating under poor maintenance. Air ingress happens through several pathways. The conservator breathing system is the most obvious one. But we also see it through leaks in gaskets and seals, faulty diaphragms of bladders, and ineffective silica gel breathers. Each of these entry points allows atmospheric air to contaminate your transformer oil. The composition of this air is roughly 21% oxygen and 78% nitrogen. Here's where things get serious. Oxygen itself does not cause faults, but oxygen is a powerful aging accelerator. According to IEC 6599, oxygen accelerates oxidation of oil, aging of paper insulation, sludge formation, and moisture generation. Oxygen plus heat plus moisture is the worst combination for transformer life. This combination creates a cascade of chemical reactions that can reduce your transformer's lifespan by decades. Nitrogen, on the other hand, is an inert gas. It does not react with oil or paper. This makes nitrogen our reference point. When nitrogen levels change, it tells us about air ingress. When nitrogen remains stable but oxygen decreases, it indicates internal oxygen consumption through oxidation processes. Typical healthy oxygen levels are usually below 1000 ppm, but absolute values matter less than trend and ratio. A transformer with 500 ppm oxygen that's increasing rapidly is more concerning than one with 800 ppm that's remained stable for years. Nitrogen should remain stable once the system is sealed. Any significant increase in nitrogen indicates fresh air ingress. The O2/N2 ratio is our key diagnostic tool. In atmospheric air, this ratio is approximately 0.27 based on the 21% oxygen and 78% nitrogen composition. This ratio reveals air ingress severity. When we see this ratio in transformer oil matching atmospheric levels, we know we have active air ingress. But here's where engineering interpretation becomes crucial. An increasing O2/N2 ratio over time suggests excessive air ingress or breather malfunction. The action is mechanical, not electrical. You need to inspect your conservator system, check your silica gel breather, examine gaskets and flanges. However, when you see high oxygen with stable nitrogen, this ratio helps distinguish leakage versus internal aging. If oxygen is being consumed internally while nitrogen remains constant, your O2/N2 ratio will decrease. This is a chemical aging warning. Your transformer oil is actively oxidizing, consuming oxygen in the process. Let me walk you through three scenarios. First, a healthy sealed system shows stable low levels of both gases with a consistent ratio. Second, external air ingress shows increasing levels of both gases while maintaining the atmospheric ratio of around 0.25 to 0.3. Third, internal chemical aging shows decreasing oxygen with stable nitrogen, resulting in a declining ratio. When you encounter abnormal O2N2 ratios, your corrective actions are clear. Inspect the silica gel breather for saturation or channeling. Check the conservator diaphragm or bladder for tears or deterioration. Examine gaskets and flanges for leaks. Review oil oxidation indicators like acidity and interfacial tension. These are maintenance issues, not electrical faults. The engineering reality is sobering. Many transformers fail early not due to faults but due to poor sealing. Air ingress is silent and gradual. By the time you notice the effects through other tests, significant damage may already be done. The O2N2 ratio gives you early warning. Consider this scenario. You have two identical transformers. One maintains proper sealing with an O2N2 ratio below 0.2. The other has a small gasket leak, allowing gradual air ingress. Over 10 years, the sealed transformer operates normally. The leaking transformer experiences accelerated oil oxidation, paper insulation degradation, and moisture accumulation. Guess which one fails first? Oxygen is silent, nitrogen is neutral. Together, they expose negligence. A transformer that breeds incorrectly ages rapidly, even without faults. Your DGA program must monitor these environmental gases as closely as fault gases. The ratio between them tells a story that absolute values cannot. The technical standards are clear. IEC 6599 provides the framework for understanding oxygen's role in transformer aging. IEEE C 57.104 offers guidance on interpreting gas ratios. But standards are just tools. Engineering judgment combines these guidelines with trending analysis and system knowledge. Remember, every transformer has its baseline. A new transformer might show very low oxygen and nitrogen levels. An older transformer with a breathing conservator will have higher baseline levels. What matters is the trend and the ratio. Sudden changes indicate problems. Gradual increases suggest normal breathing. Rapid oxygen consumption warns of active oxidation. Your maintenance strategy should include regular monitoring of the O2N2 ratio. Establish baselines for each transformer. Set trending alerts for ratio changes. Investigate mechanical issues when the ratio increases. Address chemical aging when the ratio decreases. This proactive approach prevents premature failures. The cost of ignoring these environmental gases is enormous. Transformer replacement costs run into crores. Unplanned outages disrupt operations. Emergency repairs are expensive and risky. All of this can be prevented by understanding what oxygen and nitrogen are telling you about your transformer's health. In conclusion, the O2N2 ratio is more than just another DGA parameter. It's your window into transformer sealing integrity and chemical aging processes. Master this ratio and you master a critical aspect of transformer maintenance. Your transformers will thank you with longer life, better performance and fewer surprises. The silent threat of air ingress becomes manageable when you know how to listen to what these environmental gases are saying.
So friends, this is the real meaning of oxygen and nitrogen in DGA. Nitrogen is neutral. Oxygen is aggressive. Nitrogen alone does no damage. But oxygen combined with heat and moisture destroys paper insulation over time. Remember these rules forever. High N2 alone, normal breathing. Rising O2, air ingress. High O2N2 ratio, sealing or breather problem. When oxygen increases, you don't wait for faults. You inspect breathers, you check conservators, you verify sealing, and you control moisture. If this explanation helped you think like a condition monitoring specialist, then support Electroverse. Like this video. It helps serious engineering content reach professionals. Comment below. Have you seen high O2 without hydrocarbon faults? Subscribe, because Electroverse teaches prevention, not just diagnosis. This completes the full DGA gas family. Next, we build complete DGA decision trees, real field case studies, and life extension strategies. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.